just to have the clarity that we are talking about two, understand. Here we have a building, the building is marked in blue, and we have a tower, which is again a building, just a building with a greater height, right? This is the ground, and here in this situation we have been given the angle of elevation of the top of the tower from the top of the building and the angle of elevation of the top of the tower from the foot of the building, right? So basically we have been given these two values, alpha and beta, where alpha is the angle of elevation of the top of the tower from the point of view of top of the building, and beta is the angle of elevation of top of the tower from the bottom of the building. And the two heights, either of the heights will be given to us and the other height has to be found out, right? So here let's call this h subscript t, the height of the tower, and let's call this h subscript b, the height of the building. Let's see how exactly we can interrelate these two entities and then solve a problem related to this, right? So here we can see that there are two right angle triangles that are created. One is this one and the other is this one. Always, as we used to do, let's mark points. Let's mark this as T, let's mark this as C, A and B. So we have a triangle TBC, or I should call it TCB, and the other one as T. Now this point is not marked, let's call that a point D. So we have another right angle triangle TDA. So in right angle triangle TDA, if we apply tan, again why tan? Because hypotenuse is not involved. So tan of alpha is nothing but TD over AD, right? So this is the tan that we have applied. Now similarly we have to apply tan in the other right angle triangle, which is nothing but TCB. Now when we do that, tan of beta is nothing but, as you can see, opposite upon adjacent. Here opposite is TC, which is nothing but the height of the tower upon BC. Now we need to understand that TD, this particular length, is nothing but the height of the tower minus the height of the building. Why? Because this particular length is same as this particular length. Reason being, this particular quadrilateral ABCD is a rectangle. Reason being, these two are right angles, so these two also will be right angles. This is naturally a right angle. So now since all the four are 90 degrees, the quadrilateral ABCD becomes a rectangle, making the opposite sides equal. So if this is h subscript b, even CD is h subscript b. Now TD becomes h subscript t minus h subscript b, right? One more thing we need to understand, that AD and BC are also equal. So in both these equations, the denominator is same, right? So what we can do is bring the denominator on the other side. We can write AD as TD upon tan alpha. Now likewise here for the second equation, we can say BC is TC over tan beta, right? Now since we just said AD and BC are equal, so we will write quadrilateral ABCD is a rectangle. Reason, we just wrote that three of the angles are 90 degrees. So therefore AD is equal to BC. Opposite sides of a rectangle are equal. So both these are equal, meaning TD over tan alpha is equal to TC over tan beta. Now as we just discussed, TD is nothing but HT minus HB, right? So HT minus HB over tan alpha is equal to TC over tan beta. Now TC is nothing but HT, right? HT over tan of beta. Now we can isolate one of the entities and find out a formula relating one to the other. Let's go ahead and do that. Let's cross multiply both the things. So what we get here is HT tan beta minus HB tan beta On the other side we have ht tan alpha. Right, now what we can do is bring all the HTs on one side and HB on the other, so that we can get a formula of HB in terms of HT alpha and beta. So this term goes on the other side, becomes plus HB tan alpha. This comes here, so it becomes minus HT tan alpha. So taking HT common, we can write HT into tan beta minus tan alpha is equal to, on the other side as I said, it's HB tan beta. Now using this relation you can get HT as HB tan beta over tan beta minus tan alpha, or on the other hand you can get HB as HT tan beta minus tan alpha over tan beta. So I leave that up to you. Depending on the problem you can use either of them. So this formula will work when you have two buildings, or just to have that understanding that both of them are of different heights. We call one of them a building and the other as a tower, because a tower is a building which is of a greater height, right? So we have a tower and a building. Then if angle of elevations of the top and the bottom, rather angle of elevations of the top of the tower are given with the point of view of top of the building and bottom of the building, in this case alpha and beta, and either of the two heights are given, the other height can be very easily found out. Now on the basis of this, let's solve one problem which has absolutely the same concept and use this formula over here, or we can do it by a simpler process that we have done here with numbers. In fact, let's go and see the problem. Here it goes, and it says the angle of depression of the top of the building from the top of the tower is 30 degrees and angle of elevation of the top of the tower from the bottom of the building is 45 degrees. And if the height of the tower is given as 20 meters, then find the height of the building. So let's try and recreate the scene. The same structure will be applicable here. There is a building and at the same time there is a tower. So we are using the same colors so that we can correlate things. The very first information that is given to us is the angle of depression of the top of the building from the top of the tower. So try and understand, this is the top of the tower. We have been given the angle of depression of the top of the building. So this is the top of the building, this is the top of the tower, this is the horizontal line, then this angle is the angle of depression. Now as we have done this in one of the previous problems, that here the angle of depression will be same as the angle of elevation of the top of the tower from the top of the building, which is what exactly alpha is in this case. So it's just that the language is a bit twisted, but the information is same. It says that the angle of depression of the top of the building from the top of the tower is 30 degrees. That means this angle is also 30 degrees, which is the angle of elevation of the top of the tower from the top of the building. Now after that we have also been given angle of elevation of the top of the tower, which is this, from the bottom of the building, right? So we connect these two lines, 45 degrees, and also the height of the tower is given as 20 meters. So basically in this formula HT is given to us, beta and alpha are known to us. Alpha is 30 degrees and beta is 45 degrees, and HB is what we have to find out. So first let's use this formula directly, and I leave up to you how to do this problem without using the formula. You have to do the same thing. You have to apply tan in this particular triangle. You have to apply tan in this particular triangle as well. Once you get these two ratios, then the denominators of both of them are equal, because this and this will be the denominator. Both of them will be equal, opposite sides of rectangle. You have to bring them on the other side to get TD over tan alpha, TC over tan beta, equate them and solve to get the desired value. So I've changed my mind right now. I feel let's do it without using the formula and the process which I just said. So let's apply tan in this triangle. This time I'm not naming the triangles. Let's apply tan over here. So tan 30 is going to be opposite over adjacent. So this particular value, right, let's call this x for that matter. tan 30 is going to be opposite upon adjacent, right? So again, I think we have to name all the points so that there is no problems. X over AD is tan 30, and tan 30 as we know is 1 over root 3. Likewise, tan 45, which is 1, in this triangle is going to be opposite over adjacent, so which is 20 over BC, right? Now this is equal to 1 because tan 45 is 1. Now as we just discussed here, AD and BC are going to be equal, opposite sides of the rectangle. So from this equation, x root 3, right, is equal to AD, and from this equation BC is nothing but 20. So the value of x comes as 20 over root 3. Once we get the value of x, getting the value of height of the building is easy, because height of the building is nothing but height of the tower minus the value of x, right? If I subtract this, I get this, which is nothing but equal to AB, because opposite sides of the rectangle are equal. So HB is nothing but 20 minus 20 over root 3. Solving this will give us 20 common. In the bracket, 1 minus 1 over root 3, so you can write that as root 3 minus 1 over root 3. So this is going to be the height of the building. Naturally, it is less than the height of the tower. So let's see if we get the same value by using this formula. HB is what we have to find out. So this over tan beta, HT is given as 20 meters. So this is 20 into bracket tan beta. Tan beta is tan 45, which is 1, minus tan alpha, which is 1 over root 3. So this is what left hand side is. This is how left hand side is formed. Divide this by tan beta, and tan beta is nothing but 45, right? So tan 45 is simply 1. So this is what HB is, the height of the building. And if you notice, this is what exactly we have got here, 20 minus 20 by root 3. So this will simplify as this, 20 times root 3 minus 1 upon root 3 as the height of the building. So this is the situation that we just did when there are two buildings, one with a greater height, which we call as the tower, and if either of the heights is given with the angle of elevations of the top of the greater building or the tower from the point of view of top of the building and the bottom of the building, then the other height can be very easily found out by this technique. So you can remember this formula, or you can remember the process to find out the value of height of one particular building.